Hey guys, this is lesson 4.3 for pre-algebra. So 4.3 is prime factorization and greatest common factor. So you need to write down what a prime number is and a composite number. So I'm pretty sure this is just a review, but you are going to want to write a prime number as an integer greater than 1 with exactly two factors. So like the number 13, for example, is a prime number. A composite number are all the other numbers that have multiple factors. So like the number 10 is a composite number because 1 goes into it, 2, 5, and 10 are all of its factors. All right, so prime or composite. You will be given a couple numbers and then they're going to ask you, is it prime or composite? So they gave you 23. And this was prime. It only has two factors, 1 and 23. And then 129 is composite. Now that one's a little bit tricky, but if you looked, you'd see that 3 and 43 go into 129. So don't just look at a number and assume it's prime. Always try to divide by 2 and then try to divide by 3 and then your 5 and your 10 or your 9. Remember, you can add them up and see if it divides. Which number from 10 to 20 are prime? Which numbers are prime? And which are composite? So my prime numbers and composite numbers. So try this really quickly. Push pause, and then we'll go over it. All right, so my prime numbers, well, 10 is composite because that has multiple factors. 11 is prime. 12 is composite, 13 is prime, 14 is composite, 15 is composite, 16 is composite, 17 is prime, 18 is composite, 19 is prime, and 20 is a composite number. All right, so prime factorization. This is really fun. I know you might not think that, but whenever they want you to do the prime factorization of a number, you have to do a factor tree. I enjoy factor trees just because it's like a little puzzle that you're trying to figure out. So what you do is you start with the number. So they started with 825. From that, I draw a tree and I put two numbers when multiplied together equal 825. So they did 5 times 165, and then whenever you get to a prime number, you circle it. And then they did 5 times 33, and then they did 3 times 11. So my prime factorization is this, where you have 3 times 5 squared times 11. That is the prime factorization. It's not the tree, it's what you get as an answer, the whole listing out of the prime numbers. So let's try 72 together, and then you can try the other three. So 72, if it ends in 2, I know it can go into, it's a even number. So I do 2 times 36, and I circle 2 because that's a prime number. 36 is 2 times 18, and I circle 2. And then 18 is 2 times 9, and I circle 2. And then 9 is 3 times 3, and I circle both of them. So I circled all of my prime numbers. Now for the answer, I write them out, but I use exponents. So I have 1, 2, 3 2s, so I have 2 to the third power, times 2 3s, so times 3 squared. Now, if you took out your calculator and tried that, 2 to the third power is 2 times 2 times 2, which is 8, times 3 to the second power, which is 3 times 3, which is 9. 8 times 9 is 72. So I can always check my work. Make sure you get this answer right here. So try these next three, and then we'll go over them. All right, 121, you can do 11 times 12, and 11 is a prime number. and 12 is 3 times 4. 3 is a prime number, and 4 is 2 times 2. So now I write it out and I get 2 squared times 3 times 11. So 2 squared is 4 times 3 is 12 times 11 is 121. So there's my answer, and then I checked it. All right, 225. So right off the top of my head, I know 5 goes into 225. I don't know exactly, so I'm going to do a little calculating over here. 5 goes into 20 4 times, 22 4 times, which is 20, and then I have my 5, so it's 45. 5 times 45, so then 45 is 5 times 9, and 9 is 3 times 3. So my answer is 3 squared times 5 squared. So let's check it. 3 squared is 9, and then 5 squared is 25. 9 times 25, so 9 times 25. 9 times 5 is 45, 9 times 2 is 18, plus 4 is 22. So it's 225, so that is correct. Now the last one is 236. So you can do a multiple of ways. You can do 2 times something, or you could try 3 times something. I'm going to try 2 just because it's the easiest. 2 into 236. 2 goes into 2 once. 2 goes into 3 once. And then 2 goes into 16 8 times. So it's 118. So then I have 2. Half of 100 is 50. Half of 18 is 9. So that's 59. Now, I have my 2 2's. Now I have 59. So now I have to decide, is that a prime or composite number? Well, if I do 3 into 59, 3 goes into 5 one time, and then I'm left with 29. Does 3 go into 29? No, it goes into 30. So it doesn't work for 2, doesn't work for 3, doesn't work for 5, doesn't work for 10. So then my last one would be to check 9. Well, 5 plus 9 is 14, and 9 does not divide into 14. So if I try to do 9 into 59, it's not going to work. So that is a prime number. So it's 2 squared times 59. Okay, so the greatest common factor is the GCF. So GCF should be a review for you, but now they're going to throw in letters. So if I asked you to find the GCF of a pair of numbers, like 40 and 60, what you do is you do the factor tree and then you write down your answer. 2 to the third times 5 and 2 squared times 3 times 5. And then you look at what they have in common, because it's the greatest common factor. So they both have 2 2's, so that's where they got this from. And they both have a 5, so that's where they got that from. So 2 times 2 is 4 times 5 is 20. So the GCF of 40 and 60 is 20. You don't have to write that down yet. Now, this one is 6a cubed b and 4a squared b. So you'd write it out, 2 times 3, and then 2 times 2. And look what they have in common. Well, they both have a 2, so that's where they put that. Now, this is a to the third power, and this is a squared. So they both have 2 a's, so that's where they got the a squared, and then they both have a b. So then my answer is 2a squared b. So let's try A together first. So I have 8 and 20. So I'm going to make trees for each number. And they're smaller numbers, so it should be a little bit easier. 2 times 4, and then 2 times 2. So my tree for 8 equals 2 to the third power. 20 is 2 times 10. 10 is 2 times 5. So this is 2, so 20 is 2 squared times 5. Now look at what they have in common. Well, they both have 2 to the second power. So that is just your answer. 2 to the second power equals 4. So the greatest common factor of those two numbers is 4. So try 12 and 87. All right, so 12, that's an easy one. That's 2 times 6, and then 6 is 2 times 3. So I have 2 squared times 3 for 12. 2 squared times 3. Now, 87. Okay, so it doesn't go into 2. Now I need to do 87 into 3. So 3 goes into 8 twice, which is 6. And then I have 27, or whoops, 2, and then I bring the 7 down. 3 goes into 27 9 times. So it's 3 times 29. And then 29, I look at that, well 2 can't go into it. 3 doesn't go into 29, it goes into 27. So that is a prime number. So then I have 3, and so 87 is 3 times 29. So what do they have in common? Well, they both have the number 3 in common. So 3 is the GCF of 12 and 87. So let's do this next one together. So we have 12 and 8. So 12 is 2 times 6, and then 2 times 3. So it's 2 squared times 3. 8 is 2 times 4, and then 2 times 2, so that's 2 to the third power. So they both have 2 squared in common. They both have 2 squared in common, which is 4. And then if you look at them, they both have 1 R in common. Because 8 has 1 and 12 has 3, but we're just looking at what they have in common. So my greatest common factor is 4R. Now, for D, I have 15 and 45, so 15 and 45, so make your tree. 3 times 5, that's a nice easy one. 5 times 9. Okay, so what do they have in common? Well, they both have a 3 and they both have a 5. See, this 3 goes with this 3 and this 5 goes with that 5. So then they both have a 3 and a 5, which is 15. And then you look at what they have in common for their letters. What do they have in common for their letters? Well, they both have an M. So it's 15M is the GCF. That is it for your note.